In this video, we show calendars. While the role of calendars is limited in Automic Automation, since they are static objects, there's quite a bit of functional power to them. Calendars cannot be used alone. Instead, they are referenced by other objects in the solution. We find them used mostly in tasks, in other words, individual objects executed or automated by workflows and schedules. The purpose of a calendar is to designate days. We build a calendar and define events. A calendar event designates any number of days based on explicit selection, say March 2nd, 4th, and 27th, or cycles, say every Saturday or the first of the month. The calendar itself is not referenced by workflow and schedule tasks. Instead, they reference the calendar events. By referencing, we simply mean this task can execute on days designated by the calendar events every Saturday. The task will then execute every Saturday. We can also stipulate that the task should withhold execution on those days. Let's quickly show how to create a calendar and add calendar events. We start the process assembly perspective, which is where configuration design takes place. We create a folder and create a calendar. We recommend adding a title, which is a description for the objects. This makes it easier to search for and find our objects. A calendar requires at least one event, which is why every new calendar comes with a static event in which we can set explicit dates. Let's create a new calendar event instead. These are the available calendar event types. We create a weekly event that designates every Saturday. This is a fairly simple task. We simply select Saturday and click Save and View. This will designate every Saturday. When the calendar event is selected, the days remain highlighted in the calendar. Moving on, we'll explore the other calendar event types conceptually, since the process is the same for all of them. Calendar events are simple. They designate days. They are then used as an execution mask in workflow and schedule tasks to either allow or deny executions. There are 5 types in addition to the non-recurring. We first consider the cyclical events, namely weekly, monthly, and yearly. We begin with the weekly calendar event, which designates days using week-based definitions. In our first example, we used every Saturday and selecting more than one day as possible. We can also specify an interval, designate Saturdays every week, or every other week, or every 3 weeks, and so on. The CW limit makes it possible to narrow the perimeter of our calendar events with a starting and ending calendar week. The monthly calendar event designates days over months. You can either target days of the month explicitly or specify a cycle, say every 5 days. You have the option of selecting days from the beginning or the end. Days 1 and 2 from the end will always designate the last 2 days of every month, irrespective of the number of days in that month. Just like the weekly, the monthly calendar events makes it possible to set limits. Your days could be designated for the months ranging from April to August, for example. The yearly calendar event makes it possible to designate days over annual time ranges. You can either target them explicitly or use cycles. The yearly limits mean your events will be valid, say from 2021 to 2024. There is no difficulty in cycle-based calendar events. Group and offset functions are much more complex. Let's consider them. We start with group. Grouping allows us to combine multiple events into a new group event and use Boolean functions and, or, and not to connect them via union, intersection, or subtraction. With the Group Existing Events function, you can combine already available events into one. In our events, we use the two existing events which we created earlier, the last 2 days of the month and every Saturday. The resulting calendar events designates both. This is a Boolean OR function. Under the advanced options, we find the intersect function, which allows us to designate days that meet both requirements. This is a Boolean AND function. We start with the baseline events, which is every Saturday, and specify an intersect event, in this case, a monthly event which designates the first 3 days of every month. If one of those days is a Saturday, it will be designated. If not, that particular month will be skipped. We end our explanation of the group event with a quick demo. Here we show how to create a group and use the subtract function to create a Boolean not. Our aim is to create a business days calendar event because it's very likely that you will be faced with automation requirements whereby batch jobs can only execute on business days to include Monday through Friday and exclude all holidays. We start with a weekly calendar event called weekdays. This event designates every day of the week, but not weekends. So we have left Saturdays and Sundays out. We search our weekdays calendar event, since this will be our baseline. This time we use the subtract function. We want to remove US holidays from our Monday to Friday cycle. While administration and client zero functions are entirely out of scope, you should be aware that out of the box, Automic Automation comes with predefined holiday calendars for many countries. Some examples, like Groundhog Day, probably don't apply to your organization, and you can ask your administrator to simply remove them. Predefined calendars are stored on the central administration component of the solution called Client Zero, but it can be referenced in all other clients. There is a calendar event called Total on the US holidays calendar which we can use. It groups all US holidays like Independence Day and New Year's Eve. We search for Total and select the American one. When we search for Total, we find the total events for every country. This produces the result we expect. The last calendar event type is the offset function, which is by far the most complex. Offsets are designed to move the designation either forward or back when the day designated by the baseline event is not what we want. Typical examples are things like designate the first day of the month as long as it's a working day. If not working, then offset to the next day. We consider the easiest kind, which is the simple offsets. This function is designed to let you reuse standard calendar events like first of the month, and then offset by set days. Postpone offsets forward, and advance offsets back. The matching offset allows you to offset from the baseline events using another event instead of set days. The baseline event sets the designated day, and the matching offset event stipulates where the offset should go to. In our example, our existing event is the first of the month. Designated days will be the first of each month. However, we have a secondary requirement. Designated days can only be business days, no weekends and no holidays. We simply reference the business days event as the target. Continuing with the matching offsets, we consider the additional offset, which sets a hard offset on the existing events before the offset event is applied. Let's consider an example. You want to designate the second last day of the month, and it has to be a working day. The last part of the offsets event is the exception, which allows us to define the behavior for cases where the existing event collides with another. In other words, the baseline event designates a day which is forbidden by the collision event. Acceptable behaviors are skip, whereby no execution occurs, advanced or postponed by a hard number of days, or offset using a calendar event. In our example, the existing event is first of the month. However, we want to avoid holidays and postpone to the next business day instead. We use the US calendar total events in the collision field and simply match to the weekday's calendar events. If January 1st is a holiday and a Friday, the next designated day will be Monday 4th, since Saturday and Sunday are not weekdays. The offsets also means that if the 4th were a holiday, it would again offset to the next weekday, which would be Tuesday 5th.